Okay, I believe this is Algebra 2. Let me just check. Do we have, like, imaginary numbers? Yeah, cool. Okay. So what this is we're only looking at part 1. There's some stuff in part 2, which is stapled to the back of part 1. I know, crazy that. That I want to go over with you guys more in detail. But, final review part 1. So the purpose of this is to give assistance if you're having trouble with any of the problems, and to hopefully refresh your memory on some things. When you're doing these, you should have your notes available. You should be looking at your notes at the port, port is a word, but it's not the word I meant to say. At the part of your notes that affect this. So if we're solving systems by graphing, you should have your notes out from August that show you how to do this. So, what we want to do is, yeah?
There's significant amount of coolant leakage. Just so you know.
Okay. So what we want to do is we want to graph these. Sorry about that. My wife just came in and told me something about the car. So I was thinking and forgot to hit pause. Anyway. So what we're going to do is we're going to multiply by 8, and that's going to clear the fraction. So now we have negative 2y minus x equals 8. Okay? And the reason we do that is to make our lives easier. So this is in standard form. So what standard form allows us to do is graph with the intercepts. So we can plug a 0 in for y, and we know that x then is negative 8. Plug a 0 in for x, and we know that y is negative 4. Okay? So we can then connect those dots, and that's our bottom line. Now the top one, I think it's going to be a little bit easier if we go ahead and turn that into slope-intercept form. So we're going to divide everything by negative 3. So we get y equals 4/3. The negatives cancel out. X minus 7. So we plot negative 7. That's our intercept. And then our slope is 4/3. So we're going to go up 4 over 3. And there we go. And that would be our answer. Now, here's the thing. That doesn't hit perfectly. So solving it by graphing, we can say that's where they meet. But there's really no way to be specific. To really solve this, we would really have to use algebra, either elimination or substitution. So, moving on to number 2. With these two, I'm going to put them into slope-intercept form. So I'm going to move the y over. So that gives me negative 4y equals negative 11x plus 36. Divide both sides by negative 4, and I get y equals 11/4 x plus 8, or minus 8, because I divided by a negative 4. So I go down to negative 8, plot my intercept, go up 11 over 4, and that's my line. Do the same thing for the bottom one. I'm going to add 2y to both sides. I get 2y equals negative 3x plus 16. Divide both sides by 2, and I get y equals negative 3/2 x plus 8. Graph that. And there I go. Again, they don't quite meet up exactly on a point. It's kind of a half line. Now I could guess at what they are, but if this comes up, if it's something like that, just go ahead and circle it if it's not on an actual point. Same idea for these ones. I'm going to not talk you through these. But I will kind of show you the answers. Oh, on 3, they end up being the same line. So the answer is all of it. Okay, systems of equations. What we'd want to do is figure out whether it's addition, subtraction, if it's elimination, or whether the best way to go about it is substitution. So for number 5, I see that 2y and that negative 2y, so I'm going to add them together. That gives me negative 8x equals negative 48. Divide both sides by negative 8. And I get x equals 6. What I then want to do is go back and plug 6 into either one of the equations, and I should get the same answer. Well, I will get the same answer if I did it right. So here I have negative 5 times 6 instead of x, because x equals 6. See what I did there? I took this and plugged it in right there. So that gives me negative 30 minus 2y equals negative 26. I'm going to add 30 to both sides. I get negative 2y equals 4. Divide both sides by 2, negative 2, and I get y equals negative 2. That gives me the point or intersection of x equals 6 times negative 2. Or no, 6 times negative 2. 6, negative 2. The x is 6, the y is negative 2. Same general idea for number 6. I'm going to add them together. So that gives me negative 3y equals 27. Divide both sides by negative 3, and I get y equals negative 9. Then take that negative 9 and plug it into one of my equations. So I plugged it into the bottom one. 6x plus 7 times negative 9 equals negative 3. 6x minus 63 equals negative 3. Add 63 to both sides. I get 6x equals 60. Divide both sides by 6, and I get x equals 10. And that gives us a point of 10, negative 9. So this is basically the process for, I don't know what just happened. That was weird. Okay. There we go. So I don't necessarily think you guys need to be talked through the rest of them. So if you guys should be able to sit there and figure out the rest of the systems of equations. If you have any specific problems, go ahead and email me. I do have different parts of them recorded. So, but yeah, well, anyway, I'll just go ahead and put those out now. So, 7's pretty easy. When you subtract it, you eliminate everything. So you get 0 equals negative 1. That's never true, so it's no solution. With 8, what you're going to need to do is multiply or subtract the bottom one. You can multiply it by negative 1 and add, or just subtract. So you get negative 3x minus a negative 2x. So that gives you negative x. 4y minus 4y is 0. Negative 22 minus a negative 16 turns into negative 22 plus 16. So we get negative 6. Multiply both sides by negative 1, and we get x equals 6. We then take the 6, plug it back in, so we get negative 3 times 6 plus 4y equals negative 22. That gives me negative 18. Hey, Salem. Plus 4y equals negative 22. Add 18 to both sides. We get 4y equals negative 4, or y equals negative 1, which gives us an answer of 6, negative 1. Moving on. 9. We're going to multiply that bottom one by 3, so we can get rid of the y's. That gives us negative 12x minus 6y equals 12. Negative 12x plus 6y equals 6. keep track of your negatives here. So we get negative 24x, the y's disappear, equals 72. Divide both sides by negative 24, and we get x equals negative 3. Plug that negative 3 back in. We get 12 plus 2y equals 20. Subtract 12 from both sides, we get 2y equals 8, or y equals 4 after we divide by 2. That gives us a point of negative 3, 4. On to number 10. So 10, again, I'm going to multiply the bottom one by 2 to get rid of the y's. So the top one doesn't change. Negative 5x minus 8y equals negative 15. The bottom one, 2x plus 8y equals 30. Add them together. Negative 3x equals positive 15. Divide by negative 3, and we get x equals negative 5. We're going to go back and plug that x in. I decided to do it up top, or to the bottom one. So we already have that x by itself. And we go negative 5 plus 4y equals 15. Add 5 to both sides. We get 4y equals 20, or y equals 5. So we get negative 5, 5. For number 11, what I decided to do was do some substitution just to show you guys how that would work. So I'm going to solve the top one for y, okay? I'm going to subtract 6x from both sides, and I get that. And then divide everything by 2, and I get y equals negative 3x plus 2. I'm then going to take what y equals on the top equation and plug it in for y on the bottom equation. Negative 4, whoa, I just did not mean to do that. Negative 4x minus 3, and then I put in the negative 3x plus 2 equals negative 6. Negative 4x plus 9x minus 6 equals negative 6, and there you see it. So then 5x equals 0, x equals 0. Plug the 0 back in, you get y equals 2. Number 12, I'm going to multiply the top one by 2. That gives me negative 12x minus 16y equals 32. Bottom one, I'm going to multiply it by negative 3. So that gives me positive 12x plus 27y equals 21, negative 21. So again, what I did was multiply the top one by 2, the bottom one by negative 3, and that gave me those x's that I can get rid of, positive 12, negative 12. That gives me 11y equals 11, or y equals 1. I can then go and plug that y back in. Negative 4x minus 9 equals 7. Add 9 to both sides. I get 4x equals 16. Divide by negative 4, and I get x equals negative 4. So that gives me my point of negative 4, 1. Next up is something you guys are a bit more familiar with. We have to sketch the graph of each function. We have negative 2x squared minus 4x minus 4. So these are the steps we just went over. So you want to identify your ABC, then you want to find your negative b over 2a. Here that'd be a negative 4 over 2 times negative 2. That gives me 4 over negative 2, or negative 4, or negative 1. So that puts my axis of symmetry right there. I then find my vertex by plugging that negative 1 back into the equation for x. Y equals negative 2 times negative 1 squared, minus 4 times negative 1, minus 4. Remember, these are the steps for how to graph a quadratic equation from standard form. That gives me negative 2 times 1 plus 4 minus 4. The 4's cancel out. And I get y equals negative 2. That gives me my vertex at negative 1, negative 2. Graph that. I then graph 0c, which in this case would be 0, negative 4. Flip it over my axis of symmetry. Connect the dots. Same general idea for the next one. Really, the only difference between 13 and 14 is 14 has a plus 4. So we're going to go negative b over 2a, negative 4 over 2 times negative 2. So I'm going to get, instead of a negative 1, I'm going to get a positive 1 for my axis of symmetry. I'm going to go back and plug that positive 1 into the equation. Again, the 4's cancel out, and I end up with negative 2 as my y. So that gives me a vertex of 1, negative 2. Graph that. Graph 0c, 0, negative 4. Flip it over to 2, negative 4. And connect the dots.